Welcome, welcome. My name is Lloyd Borrell. I'm your host. Today, I'm thrilled to have as my guest electrician and EMF expert, Mr. Dave Stetzer. With a career spanning over 40 years, Dave Stetzer is widely regarded as one of the world's foremost authorities on what is commonly termed dirty electricity. Mr. Dave Stetzer, welcome to the EMF Health Summit.
Well, thank you.
Thank you, sir. Thank you so much for being here. So, dirty electricity, the name kind of gives it away. But if you could explain to us what dirty electricity is and why it's important.
Okay, well, actually, Professor Martin Graham, who was a professor emeritus from UC Berkeley, he had over 40 patents to his name. We discovered this back about 1997, 98, something like that. And he wrote a white paper, and he called it electrical pollution. And another word was ubiquitous pollutant, meaning it's everywhere. And so somewhere along the line, it got evolved into dirty electricity. But basically what it is with modern day electronic devices, we're turning things on and off really fast. And so we get a little arc, as we do it, if you go by your light switch and you turn it on real slow. And so we get these, what we call transients. So high frequency transients. You really want a really nice, smooth sinusoidal sine wave. And what happens is you don't get it. It's being chopped up, turning on and off real fast. You get these little arcing and things like that. So you get these high frequency transients that are actually on the building's wires.
Okay. So it's been around for quite a long time. Well, certainly, as you're saying here, the research, we're talking about the 1970s. But what interests a lot of people, because few people are aware of this, we agreed, I'm aware of it, you're aware of it, and there are some people that are aware of it, but it's not mainstream by any means. So my question is, about the science. If we could talk a little bit about the science, because there is quite a lot of science on this now. If you could, what studies are there, and how strong is this science?
Well, okay, the science is very strong. The problem is when we say everybody, very few, you're right when you say people aren't aware of it, because it isn't something you see, you can smell, taste, touch, something like that. But, and actually even to see it, you have to have expensive equipment. For example, we always used an oscilloscope, and so we always seen their waveforms then. Back in the 70s, I was using an oscilloscope. But the average person can't afford a oscilloscope, or certainly not going to invest in one that if you're not going to use it, if you don't do it for a living. So they're around $5,000. So, But if you take the oscilloscope, you can actually see and you can calculate this. Now the Russians, they've done a lot more research on it than we have, and way back. And they're saying that, well, first of all, if you made the human body into an electrical model, it would look like 3 resistors and 2 capacitors. Well, basically a capacitor is a short to high frequency. So when you get above 2 kilohertz, 2000 hertz or 2000 cycles per second, all that energy dissipates internal to the human body. So the Russians have standards and already had standards in place. So they're saying, okay, look, if you say it's like 250 volts per meter that you're allowed, well, it goes down to 25 if it goes above 2 kilohertz, at 2 kilohertz or above, because all the energy, there isn't 10 times more energy, but it's going down, it's going internal, so it does more damage. So it's been around for a long time. The science is there. Professor Magda Havas from Canada has done a lot of research on it with that, and actually cleaning it up. If you want to, in science, if you want to show that A causes B, if we can figure a way of removing A and then we can put A back, B goes away and comes back each time, then we can do that. And so we figured out a way of doing that. She's done a lot of research on it. Professor Sam Milham, who is world famous epidemiologist, written books on dirty electricity, everything. He's former head of the health department in Washington State. He's done a lot of research. Stephen Genesis, lots of Russians have checked this. Professor Yuri Grigoriev, who they call the grandfather of electromagnetic radiation. Professor Nicotina Valentina, she's the grandmother of electromagnetic radiation. They're older, but they're still, active. in research on this. Vitaly Resnick, the list goes on. So it's not something that it's written up and published in the National Enquirer. This stuff has
Yeah.
been done and it's published in medical journals. And I always tell people maybe the Dalai Lama can change his blood sugar, for example, psychosomatically, but you or I can't. And we know if we change that dirty electricity number on the wall, for example, if we can lower that, blood sugar changes. Free radicals in the blood change.
Yes.
These are numbers that can be plotted against numbers. pH
Yes.
in the saliva changes.
Yes.
The neurotransmitters will change.
Mm.
Your urine, for example.
Mm-hmm.
And all in a short time. I mean, like 8 hours, like blood sugar, like 20 minutes to an hour. Your blood sugar can change.
Yes. So there is all this science, and because we've actually spoke before on this subject, some references that you shared with me before, I didn't know about these. These are actually what you gave me previously, are a book by a gentleman called J. Patrick Riley called Electrical Stimulation and Electropathology, and also a book called The Effects of Electric Shock on Man by Charles Dalziel, which are also references which people can check out. There's also a lot of research on your website.
Yes, there is. Yes. Research with blood sugar, MS, a lot of research on MS. Havis done some with other people also. Blood sugar, there's 22 million diabetics, diagnosed diabetics. This is an old number now, but it comes to mind a few years ago. It was 22 million diagnosed diabetics in the United States alone. Why? I mean, when I went to school, and I'm old, but I went to school and nobody in my class was diabetic. And my sister and I were talking one time here a while ago, and we said, we think we had a great grandmother who said she was diabetic. And that's the only person we knew until now. It's like probably 25% of the population.
So there are these sciences pointing to all these adverse biological effects, which you just mentioned here, the effects on blood sugar, the effects on the neurotransmitters, notably the dopamine. And so there are these very clear, observable, very statistically significant adverse biological effects to these exposures, which we call dirty electricity. That's a common term, but there are other terms for it, intermediary frequencies. But what we're talking about is electropollution, very simply, this arcing which comes on electrical wires. So my question is, in terms of the diseases, so you mentioned diabetes, but yeah, so what can we talk about? What links, because it's emerging research, of course, and there's, it's ongoing research, but what actual links do we have, indications of association of these exposures with disease?
Well, Sam Milham, he's a world famous epidemiologist, so he'd probably be more credentialed to answer that question, because I'm not a medical doctor. I'm the measurement guy. But he calls it the diseases of the electrification of America. I think he wrote a book, and he can show that cancer rates went up. And I think New York City, Berlin, and London were the first cities to get electrified. And you could see the cancer rate, and they just spiked as soon as they did that. Another thing was the rural electrification came through here, and I live in Wisconsin, about in the 30s, okay? 35, 36, these lines, some of them are still up. We're still using the same power lines, okay? So what happened then in the South, the blacks in the South were the last to get electrified, and diabetes was almost unheard of in their population. And then all of a sudden they get electrified, and they have just as much chance of getting diabetes as any other group of people. So now after the lines went through, so it is Millam's more an epidemiologist, and he can take you right to the
Yeah.
statistics. But Havis has done research, Millam, Genesis in Canada, Dr. Stephen Genesis. There's been a lot of research on it. The books that you just mentioned isn't for the average person, but basically what it says is that if above 2 kilohertz, the energy goes above internal. It only takes like 60 microamps, millions of an amp, 60 microamps to stop a dog's heart, and 80 microamps to stop a human heart. So
Yes.
that's pretty low levels there.
Yes.
18 microamps is associated with cancer in numerous well-programmed studies, and that's by the National Institute of Health and Environmental Sciences. So you can see it doesn't take very much to cause issues.
Mm. Mm. So, and this is clearly a growing problem because, so you're talking about the studies with Dr. Sam Millen, and I know he's done some amazing work, and it's a great little book, Dirty Electricity, that he wrote, but it's so much work that he did really behind that, and studies he's done on populations and electricity. But it's a growing problem, is it not? Because of these more and more electrical devices are creating this problem. Could you just speak to that a little bit?
EPRI, that's Electrical Power Research Institute in Palo Alto, California. I think it was like 2005, I think, or something like that. They came out with a study, and or I might have that wrong, maybe 1998. Anyway, they said 70% of all the loads by 2002 was going to be nonlinear loads. Nonlinear loads is an electronic load, okay? So this is growing faster and faster and faster, okay? Even in our own homes, you can think, well, how many homes have computers and TVs? Hardly any of them don't. But now when we start to buy like a new furnace, for example, we get a variable speed frequency drive on it. If we live in the country, we get a variable speed frequency drive on our well pump. And we get a variable speed frequency drive on our heat pumps and our air conditioners and things. And these are really bad because they chop up the sine wave really bad. They put a lot of high frequency transits back. And even if you don't have one and your neighbor does, it shows up in your house because it gets back on the grid.
And then I'm thinking the switch mode power supplies also. More and more devices fitted with that. Could you speak to that?
Absolutely. All electronic equipment runs on DC current. So we have to change the AC to DC. Now, okay, your grandpa and your great-grandfather had his radio, and if you went over to his house or his TV, you could look in there and you could see these vacuum tubes, and you'd see a little filament, like a little light up. Well, that's still a linear load because actually all you're doing is the same as lighting a light bulb, okay? So you had this filament, and it boiled electrons, and it created the DC for us. Now we use diodes, solid state equipment. And the other thing is even lighting, energy efficient lighting. And the government, one of the worst things that's come out is like these compact fluorescent lights. They put between 50 kilohertz and 100 kilohertz back on, depending on the brand or wattage and thing, on every wire in your house in a neighborhood. So you could have a compact fluorescent light down at the end of the driveway, on at night, and you got 50 kilohertz right at the headboard of your bed in the wires. So it's really growing fast. Years ago, you never seen this. In 1972, there was an oil embargo, so we had to get more energy efficient. So we started using current in short pulses. For example, if you have a 60-watt light bulb, it gives us so many lumens of light. So we want to use current, less current, and we want to pulse it, turn it on, turn it off, turn it on, turn it off, and still get the same amount of lumens, but less power. Well, what happens when we're turning on and off, we get this little arc, we get these high frequency transits. And of course it affects our health.
Yeah, so it's clearly a growing problem. More and more devices, because we're trying to save the planet. This is irony of the thing. And yet it seems we're killing ourselves at the same time, slowly killing ourselves at the same time. Is that an overstatement?
That's right on the nutshell. Wind. Everybody thinks wind power is so great, right? Green. It's not green. Okay, what happens, probably the greenest is hydro, but the wind, if the wind's blowing 5 miles an hour, you want to produce electricity. If wind's blowing 30 miles an hour, we want to produce electricity. So what happens is, I'm sorry, but so what happens with this wind is we produce AC current when it's blowing. Now, the faster it blows, the more current. So then, but it's not a constant voltage. So we have to go ahead and put it back on the grid. So what happens is we take the AC, we got to turn it to DC. So then we have to go through a switch mode power supply. That creates high frequencies. Then we got to take the DC and run it through an inverter to put back on the grid. So that creates another high frequency. Now, that's kind of a doom and gloom, but it gets delivered everywhere, say. But you could take a tune filter, and the Institute of Electrical and Electronic Engineers addressed this, but nobody wants to spend the money. You can put a filter on there and clean that out. Same way with a computer industry. If you know your computer is putting 25 kilohertz back on the line, put a tune filter for 25 kilohertz right on the computer itself or right on that switch mode power supply. But yes, it's getting really bad. It's not green. It's not green. We're killing ourselves on this planet. Wind, solar, big, everybody's going solar, but your doctor bill is going to go up.
Yeah, because we've got the same phenomenon here. This AC, DC, the inverter on the other end, all this fairly sophisticated electronics, which is great. It gives us power, but the power is very harmful, potentially very harmful.
Most solar, the ones that I've seen, and I measured hundreds of times, is 20 kilohertz. It'll put 20,000 cycles, right back on every wire in the whole area. And then in North America, the lines were built for linear loads, okay, not nonlinear loads. So the neutral wire, the primary neutral, the wire that takes that current back to the substation, should be on the wire, but the wire isn't big enough. So what happened in 1992 is the Public Service Commissions of most states allowed the utilities to drive a ground rod in every pole. So now what happens is in 1998 figures by two different studies said that 70% of all the current that came out on the phase wires returns to the substation via the earth. Well, where do you stand? On the earth. I mean, recently, last summer, Milham and I were investigating some things now where people were swimming in a lake and they touched the boat dock and were electrocuted, died. So one in Alabama, and I remember the other ones were, but so it's the ground current. There's so much current in the ground, and 70%, I know it's more than that now, has to be.
So I'd like to come to that in a moment, because that's a really important topic. But just to finish on the dirty electricity, if we can. And the thing I want to stress here for people that are listening, just to emphasize this, is that, as you were saying, you put a CFL, a compact fluorescent light bulb, out to light your drive, then that is putting this dirty electricity, this electro pollution, into your bedroom, quite probably. Yeah. It's putting it on your electrical.
Without a doubt.
Yeah.
Absolutely.
Yeah.
You can go to your neighbors, we can take an oscilloscope or a meter and we can plug it in at your house and we can call your neighbor and say, hey, vary your light dimmer switch. And you can watch the meter change. And you can tell them after you see it change a couple times, you can tell them, okay, you have it half bright, you have it all the way bright, you have it dimmer. So it isn't just like, okay, I don't have any of this stuff in my house. It doesn't matter. If your neighbor's got it, which they do. So there's nobody, for me, and of course I'm electrical, that's all I've ever done. But this is the number one concern in this country, for health, in my opinion.
Yeah. I
mean, chicken pox, okay, or something like that, you get a shot for it or whatever. No, but like a lot of this stuff unless you have it, unless you have MS, you're really not concerned about it that much. But this affects everybody. There's nobody that it doesn't affect, number one. Number two, there's nobody that's not exposed to it.
Mhm.
Nobody that I can think of.
Yeah, yeah, yeah. So that's the doom and gloom.
Yeah, it is. Yeah,
And but the good news is that there is a solution, and this is what you've been working on for a number of years with Dr. Martin Graham. And there is this amazing, and the other thing is it's fairly easy to implement. This is such a great shame that more people don't know about it, but that's why we're talking about it today. And it's not terribly expensive either, not necessarily expensive. Obviously, in terms of your health, and you've got questions to ask, well, you know, what price can I put on my health? But yes, so if you could just talk about this meter, firstly, please, that you've developed and how that works.
Yes. Okay. Remember, we were at the beginning of the show. We started talking about oscilloscopes, and they're like $5,000. And when we went to Russia, I spent a lot of time in Russia and Kazakhstan and places like that because the Russians actually made weapons with these frequencies. Okay. And so we needed to know what the most biologically active frequencies and things were. Okay. And there's something called radio wave sickness, a set of symptoms. Okay. And they're the exact same symptoms as chronic fatigue, fibromyalgia, ADD, ADHD, things like that. So the Russian health department said, look, we can't afford to give everybody an oscilloscope, our sanitary stations, which would be like our health departments. We can't afford to give them an oscilloscope, train them how to run it and all that stuff. Can you make us a meter that will measure just the high frequency energy that's on the building's wires? So, well, I don't know if I can, but Martin Graham probably can. So, and he did. I mean, we tried different things and we made a meter. And I don't know if I got one laying here, but it's,
right.
You know, like it's simple. There's not even an on and off switch, okay? And you just plug it into the wire and you get this digital number that comes out. And of course, then we went to what we would call our Bureau of Standards there. And remember that 2 kilohertz number, because that's where it goes internal. If you have the number below 50 on this meter, you're for sure below 2 kilohertz. Even if it's 50, usually it's right around 2 kilohertz. Okay, so there could be some instances where it's not, but it's looking at the electrical energy that's on the building's wires, measuring dV over dt for your engineers. But how many times did that transit? That transit's a little voltage spike. How many times did it change in a given period? So we built the meter, so you can actually, the average person can build it. It's like a little over $100 or something like that. It's retails for, I think, 125 or something like that. So, you know, you can afford it. And they should last for a long, long time. I mean, you know, I guess they go bad. Somebody just gives you a new one or something, because they don't really go bad. Okay?
Yeah.
Yeah, it's electronic part, but that
Mine is I was working out actually. It's over 10 years old, and it's still good.
Yeah, I think this is a newer one because I see the cord is still tied up, but I just leave it on the desk for now. But yeah, and it's just a digital meter. You plug it in and you get this number.
So you get this number, and it's a number in GS units. But so just to make the bridge between GS units, which nobody's ever heard of, not surprisingly, unless you've studied this, and kilohertz, which most people are a little bit more familiar with. So how does that work?
Okay, well, what happened was when the Russians said we want to measure the high frequency energy that's on the building's wires. Okay, well, everybody's heard of Ohm's law and you know, Kirchhoff's law and things like that, but less people have heard of Planck's law. Maxwell Planck said that, he was a German physicist, he said energy is proportionate to frequency. That's how the higher the frequency, the more energy. That's how your microwave works. We don't have very much voltage, but you know, only 120 volts and maybe only draws 10 amps, but we have a whole lot more energy there because we've increased the frequency, okay? So energy is proportionate to frequency. So we need to take the frequency part into the equation. It has to be part of it, okay? Higher the frequency, more energy, less, okay? But we also need to look at the amplitude, the voltage. How much voltage, you know, do a 50 millivolt transient is going to have more energy than a 20 millivolt transient, okay? But if the 20 is at a higher frequency, it could actually have more. So what happened is we come up with this meter, and it really is a measurement of energy. But electrical energy is usually measured in watts, kilowatts, or joules, for example. But this is not a watt, and it's not a joule, but it's still a measurement of energy. And so this was being batted around for a long, long time. So what happened is we met in maybe 2000, something like that, in San Francisco. We had physicists from around the world. We had electrical engineers, people that, professors of engineering things, and we had this big discussion. And it got to be probably like 1 o'clock, so maybe people were hungry or something, wanted to get the meeting over or something. But finally, everybody agreed it was a measurement of energy, but it wasn't any of these joules or anything like that. So an engineer got up, he was from China, and he said, look, Ohms discovered ohms. Why don't we call it after the guys that found it, Graham and Stetzer? So we'll call it a GS unit. So everybody voted for it to be called the GS unit, and everybody went to eat, I guess. But so it kind of stuck. But it is a true measurement of energy, and there's been a lot of research done with it, published in peer-reviewed medical journals. Like I said, not the National Enquirer or something, but and it correlates. It means something. I mean, the higher that unit, the less milk production a cow will give. The lower that unit, the more milk she gives. And we can plot this on a chart. Blood sugar, you can plot blood sugar on a chart. You can plot pH in your saliva. You can plot the free radicals. You can plot the neurotransmitters, for example. That number, and most of the research says if the number is below 35, this is when all these things happen, right? But in my opinion, if it's below 50, the same thing should have happened. But that's my opinion. I'm not the doctor, and I'm not but I'm just looking at it from an engineering standpoint, where if you're below 2 kilohertz, it's not going internal, so the same thing should happen. But
Yeah.
Again, if it's below 35 is what the research says. They were the doctors, they were the professors, they did the research.
Okay. So we're looking for, in your opinion, below 50 GS units. The research is saying below 35, but I mean, when you use this unit, it flickers a bit. So yeah, if you can get between, low side of 50, that's pretty good. And again, what's important is this. It's not really the GS number, this Graham's, that's the unit number. It's the fact that this 50 corresponds to 2 kilohertz. And we know, the studies tell us that at 2 kilohertz and above, that we've got these adverse biological effects. So my question is, so you've got the meter, which is really simple, because you just plug the thing in and it gives you a number. And then so you've got this number, and then, what do you do after that? What do you do with a number? How, so that, to put it in other words, what is your recommended protocol for mitigating dirty electricity in a home?
Okay, well, again, this wasn't just a whim. We went to Russia many trips. And absolutely, these guys, they didn't want to help me at all. An American, what are you doing here? You're going to make some money. We want to make money, whatever. So when I showed them what was on their building's wires, because they have computers and they have energy efficient lights too, then it was like, oh my gosh, So then they went to help us, okay? So we developed a filter. They told us which frequencies were the most biologically active frequencies. Now they're saying between 4 kilohertz and 100 kilohertz are the most biologically active. I've rarely seen anything above 100 kilohertz on the wires, okay? So, but our filter goes beyond that. We developed a filter that takes out between 2 kilohertz and 150 really good, okay? So it's just a thing you plug in. I can just hold it up here, you can see it. It's just a 2-prong. You can plug it in upside down, okay? And that will short those high frequencies out, okay? So the average home, you got to look at where it's coming from. There's 2 sources. One's going to be is coming off the grid, and the other, because your neighbors and everything that affect you. And now with smart meters, they put 50 kilohertz back on every wire because they got to transmit, so they have that DC circuit. And like your computers, your equipment inside your house, your TVs. So you want to put them on the TV and put them on your computer first, because every time you plug one in somewhere, it lowers the numbers everywhere. So we plug them in on the TV and places like that, you will use less filters. And then you just plug the meter in after that. You get a number, you plug the filter in, and you want to see it drop significantly. And I define significant as 20%.
Mm-hmm.
If it goes down 20%, you leave it. Go to the next outlet. You need to check every outlet, but you don't need one in every outlet, okay? So then the numbers will come down. The average home takes about 20. The average home has 2 TVs and 1 computer. So if you have more, you might need a little more, a couple more, and if you have less, you probably don't need as many, okay?
Mm-hmm. Okay, yeah, very clear. So start off, just to resume, so start off putting, obviously measuring, but before that, if you identify certain electrical appliances which are causing significant dirty electricity, that's to say, you can, if you go to a certain room and you've got a very high reading and you're able to identify that it is, because I actually had this situation in my home on an electrical a light, an LED light above the shower, and I was doing a video with my son, and he put the switch on, he put the light switch on, and it boom shot to 1600 GS. And I mean, I never realized, I mean, I'd had this, we'd had this light for years, ever since this, we moved in. And it was just because we kind of switched this on. It's a light above a shower. So it's only on like, maybe 10 minutes the time you're having a shower. But my question is, before we put the filters on, can we not eliminate these certain devices? For instance, in this case, I got the electrician in, replace that light. Is that not the thing to do, is to eliminate, mitigate by, if we can, eliminating these devices which are causing this problem?
Oh, yes, but absolutely. Another thing is light dimmer switches, for example. They're really bad. Okay, so, and it's like $2.50 for a very good light switch, a single pole switch. So you could change that out pretty fast and economically, okay? Mm-hmm. And they are terrible. And in the case like that light you're talking about, and then remember, well, you say, well, yeah, but I'm not in the shower that long. But your skin is wet, and you remember that 2 kilohertz, and then you're normally like 500 ohms of impedance. Well, if your impedance really goes down because you got wet skin, and that's going to couple right into your body, right there in the shower. So, I mean, that was a good thing to get rid of it. Yes. LEDs, some of them are starting to get better now, but most of them are bad, okay? CFLs are definitely bad. And the bad part about the CFLs is not only do they put like between 50 and 100 kilohertz back on every wire, but they also radiate through space. And you can take like a 60 watt, or actually I can take an 11 watt LED, CFL. Yeah, and I can sit a foot away from it and have 27 microamps in my body. And the closer I get, the more and less, okay? Now, you say, well, 27 millionths of an amp, that isn't much. Yeah, but remember, 60 stops a dog's heart, 80 a human. And 18 microamps is associated with cancer. So this stuff, not only does it get on the wire, it comes through space, like from the CFLs. They are really one of the most dangerous things that they've come up with.
So that is internally, but what happens if you've got like everything switched off in your home, and imagine you just got like an empty shell, right, with nothing in it. You got a brand new home, an empty shell, and you plug your GS meter in there, and you've got like 500 GS units or whatever. So that means that the source of the problem is external, does it not? In which case, what can we do?
Okay, and you're right, that's what it would be. Okay, so now we want to get this home lower the numbers as we can, okay? And so if you have to, In a worst case scenario, okay, where this happens maybe in maybe 5 out of 1,000 homes, but we can't get it down. So then you have to go to the panel, the main electrical panel, because you know it's coming in off the grid, and you need to, we call it a nipple, and put like two outlets, one fed from A phase, one fed from B phase. You have two hot phases coming into the house, okay? And you plug that in there, and then you put the filter right there, the little ones. Now, some people will say, well, why don't you just build a whole house filter? And we did. That was our first idea. Most whole house filters, they have a frequency response, and they drop off at 25 kilohertz. So anything above 25 kilohertz, it still stays on the wire, okay? Number one. Number two, we did some research with the University of Wisconsin-Madison. And we took people with chronic fatigue, 20 out of 20 people. 10 people knew when it was on, knew when it was off for sure, you know. Miraculous like recovery when it was on, when it was off, they slumped back. 7 people, they got better. 3 people said, we can't tell if it's on or off. But they were going to bed 1 hour earlier or 2 hours later at night and getting up an hour earlier in the morning. But then we said, why didn't 20 out of 20 people get better? So we had the whole house filter. They didn't know, it was a double blind. But there's 2 sources. One, what's coming off the grid. And then if your computer, it still's on all the wires until it gets over to the panel to get shorted out. So that's why, then we went back and we looked at the waveforms, and the people who didn't get better had a lot of electronic equipment in their house because they were sitting there, you know, they weren't invalids, but they were very ill and they couldn't work and things like that. So then they had big screen TVs and things to help them pass the time. Well, now when we went it back and we put filters in out and about the house and did it the way we do now, we had 20 out of 20 people got miraculous recoveries.
Mm-hmm. Wow. Yeah. So
if you can't get it down, you got to go to the panel.
You got to go to the panel if it's external, and you need the two filters on the panel, one for the A and one for the B phases. So we can measure it. There is a solution, but what about the downsides? Because there is perhaps, for instance, when you have wiring errors, you know, so what is the issue there exactly? You know, can we always use these filters, or is there certain caveats?
You can always use the filters, okay? Now, you'd have to define wiring error. I know a lot of people, okay, like the electrical code says that you have to have multiple circuits in a kitchen. Okay, so a lot of times what electricians do to save money is they'll, instead of running like a 12-2 with the ground up to the top half of the outlet, and then the bottom half gets another 12-2 with ground all the way, you know, so any amount of currents on the black wire cancels in the white wire, so you don't get a big field in it. But what they'll do is they'll run like a 12-3 wire up there, and they'll feed the one top of the half of the outlet with one side of the breaker, another breaker for the bottom half, but they'll share the neutral. And so people call that a wiring error. That's not a wiring error. It's allowed by the code. Error infers something is wrong. Mm-hmm. It's not wrong. And the filters, if you have, what happens is if you got an imbalanced load, if you just plug something in, like a light bulb, to the top half of the outlet, that's fine. But if you plug something into the bottom half too, and you're running them both, and they're not exactly the same amount of current, then you're going to have this big field and nothing to cancel it. So what happens is when the filter's plugged in, it's the same as plugging, you know, like a lamp or something like that in, kinda. So then you can get this big field, but it's a 60 cycle field, and it doesn't really matter. I don't know if that doesn't go internal. So the wiring error thing is kind of a misconception. No, there are times where something's wrong. I would rather refer to that as a code violation. Mm-hmm. And you should fix it, but it wouldn't make any difference if you had a 60-watt light bulb there or the filter. Now, and the filter does remove and one thing that you should understand, because the filter draws 0.9 amps of reactive power, not real power. There's 2 kinds of power. There's real power. It really does something.
Mhm.
It's the electrons moving through the wire, down the wire, it goes through, lights your light bulb, it really runs the motor, so it's
Mhm.
real power.
Mhm.
Then there's something called apparent power or reactive power. It's the same thing, okay? What that is the magnetizing current around the line. And you don't pay for that. So when you plug the filters in, you think, yeah, but it draws current. Yes, but you don't pay for it. It's reactive power. That doesn't spin the meter. It doesn't, so if anything, your electric bill probably should go down. Sorry about that. I got out there. But so anyway, your electric bill should go down because all these little high frequency transients and extra currents, what do? They cause meters to read inaccurately. You
Uh-huh.
don't say, and there's a lot of people out there and say, oh, put this filter in, you'll save energy. These energy savers. No, there's 746 watts in a horsepower. You can't change that. You turn on a 60-watt light bulb, you got 60 watts. Sorry about that. Again, I don't know how I can do that. So anyway, you there?
Yeah, I'm still here. Don't go away.
No. Okay, there you are. Okay,
Okay.
sorry about that. I
Yeah.
apologize. I'm at work, so.
Yeah, of
But
course.
anyway, so any engineering handbook you pick up, it says, you got, it causes meters to read inaccurately. Even medical instruments will read inaccurately, and that's kind of bad too, from these high frequency transients. So what happens, you put the filters in, you take out the transients, then the meter doesn't count the zero crossings, as many zero crossings, and so they read more accurate.
Good to know. So just to finish off on the dirty electricity, and then we're going to talk a little bit more about the stray voltage, which you mentioned earlier. But so there is your solution, which is the first solution, because you did the research, you went to Russia, and you really developed this. You were the first to develop this. There are other companies that offer a similar solution now. And then there are companies that offer what's called an inline solution. So do you have any comments on that as a solution to this issue?
Well, actually, if I want brain surgery done, I don't want to go down to the local mechanic. And Graham was there. He had over 40 patents to his name. Punch his name into the internet, you're going to get thousands of hits. There would be no Ethernet, if it wasn't for him. There would be, he developed the guidance system for the ICBMs, all this stuff. Okay, so Martin Graham, electrical, all he's ever done. It's all I've ever done. Okay, is electrical. Okay, so we did the research. We are the measurement experts, things like that. A few years ago, a guy invited me to go to California, and he said, I would like to be a distributor for your filters. I have this sort of like an Amway network or pyramid business type thing. He said, can you come out and show me how they work? So I did. I took him out there. I went out there, and I'm from Wisconsin, the Midwest. Man's word is good as signature. So I went out there, and so what he did is he bought a box of filters, and he asked me all kinds of questions, and I told him the answers. So like I felt I should. If you're going to have a product, you certainly should be able to answer some questions. So he takes a hammer, knocks them apart, goes to China, and makes a knockoff. Okay, so and the meter. Then we have patents on the meter, the circuit. So he's tried to. Originally, he was buying our meter and taking the circuit board out and putting a different case on it, and so we kind of had to stop him from that. And so there are knockoffs out there. The people that are doing this, really, quite frankly, are people who are trying to make a buck off of somebody else's hard work. That's the bottom line, okay? But I mean, if people send me emails, I spend most of my day answering emails or on the phone answering questions. You can't call these other people, and one guy, they're headhunters. They find people jobs. What's that got to do with electricity? I'm not going to find anybody a job, so I don't dabble in it. I don't dabble. I'm an expert in electricity, and
Yeah.
one-stop shopping. I mean, if I can't answer your question, they'll find somebody who will.
Yeah. Okay. Okay. Good. So buyer beware on that. And so let's talk about this thing: stray electricity, stray voltage. Again, we've got lots of different terms for it. So yeah, you mentioned it earlier. Um, it's this and it seems to be a particular problem in the US, less of a problem in Europe, but basically the problem is that the utilities since what is it 19 well you'll tell me, but anyway the utility companies have been rerouting the neutral the return path via the earth. Is that basically what we're talking about here?
Yeah, he's really done your research. I have to hand to you.
Well, I listened to you the last time you explained it to me.
Well, you absorbed it like a sponge and never missed I'm really impressed. Okay, what happened again is when we built the electrical grid, we have three hot wires. We'll call them A, B, and C. And so if you have 20 amps on A and 20 amps on B and 20 amps on C, they actually oscillate between each other, okay? So there's no neutral current. So if you have 20 amps on A, 20 amps on B, and 27 on C, for example, you will have 7 amps in that neutral wire, the bottom wire. When you drive down the road, you see 3 hot wires and you see the bottom wire, okay? So that's the way electricity was. That's with linear loads, okay? Now, there's a formula and it's a vector for how much current's in the neutral. So a lot of times they didn't even put the same size wire up for the neutral as they did for the phase wires. So now what happens, fast forward to 1972, when there's this oil embargo. So now we start drawing current in short pulses in different manners, variable speed frequency drives, energy efficient light, all these things came along, right? And then, the diode came in the late 60s, so now we had switch mode power supplies, end of the vacuum tubes, integrated circuits. So we started getting more what we call nonlinear loads. Now, using that same scenario, if you have 20 amps in A, 20 amps in B, and 20 amps in C, the neutral current will calculate to 42 amps. It's twice the amount, 225%. Actually, the theoretical is 1.73 times the phase conductor, but that's at absolute zero and in a vacuum, so that doesn't exist. So in reality, it's 225%. So the electrical companies had their choice. They can go ahead and they can put up a bigger wire to handle it, or they could go ahead and put up another wire to handle it, or a cheaper method was to put the current into the ground. And so they drove a ground wire in every pole. They lobbied the public service commissions, and they allowed them to do it. Now, these public service commissioners, that's again like, you want to go to the brain surgeon and get the brain surgery done. They're appointed by the governor, okay? So they probably don't know an electron from a ground rod. So they allowed this in almost all the states, right? And so now 70% of all the current in 1998 that went out on phase wires returns back. Now, the term stray voltage is a term that I don't like, because voltage doesn't stray. It's governed by the laws of physics. It goes where people put it. So the electric utilities decide to put it in the ground. And so what happens is, if it's stray dog or stray cat, and the stray dog bites you, you're going to have to pay for that stitches yourself. But if the dog's got a collar on, you know whose dog it is, and whatever, the name and address is there, guess who pays for the stitches? So the utilities call it stray because who's responsible for it? And that's why they like that term. It's ground current, and that's what it is. I mean, if you have 10 houses on one side of the street and 10 on another, and couples there, and they all have a sewer pipe that goes into this main, say, 20-inch pipe, and the sewage pipe gets outdated when these people have 10 kids and they're washing clothes and flushing the toilet more. Okay, there's all of a sudden sewage starts bubbling up in people's basement. They don't call it stray sewage. And how do you fix it? You put a bigger pipe in, right? Or you put another pipe in. But there's another way you could fix it. You could go ahead and go out in the street and drill holes in that pipe, and the sewage will bubble out and run down the street. Now, we wouldn't call that stray sewage, but that's what they did with the electric utilities. They just drove a ground rod in all the poles, and so it's sucking that wire off. in North America, we use a grounded Y system, and then it still has to get back to the substation. The only problem is it has multiple routes back through our homes, on our pipes, through our bodies, through our cows, animals, kids.
So this electricity is there. There's no doubt about it. It's in our ground. We can observe it. You've observed it. Other researchers observed it. Dr. Magda Havas, I believe, has also done research on this. Dr. Sam Millam also. So if you could just speak to that a little bit, the research, so, okay, the electricity is there, but so what, How dangerous is it?
Well, I think it's very dangerous. I mean, if you read the reports, the high frequency stuff is very dangerous. I mean, I've read thousands of documents on it. Dr. Neil Cherry, who was Dr. Neil Cherry, who was commissioned by the European Health Department to do a review of the literature, European Parliament, but anyway, review of the literature, read hundreds of published peer-reviewed documents, cites them from around the world, universities everywhere, that this stuff causes problems. It causes, and he lists the symptoms of chronic fatigue, fibromyalgia, ADD, ADHD, all these made-up diseases of the 80s and 90s, that there's no known cause, no known cure. Well, if we remove these high frequencies from their environment without incident, these people get rid of that, and it goes away.
Right, and there are, as I understand, some very clear studies on animals, namely cows, because we say, well, animals don't lie. Can you just speak to that?
Yes, we did research on milk production. We have over 30,000 cows on film, and it shows that levels as low as 10 millivolts will cause a cow to kick the milker off, and everything, right? And so that's hundreds of times less than what the government's saying is fine. And we looked at daily milk production of a cow, and we looked at it for 500 and some days. It's a study. It's written up by Donald Hillman. He was a dairy science professor. I think there's 3 dairy science professors on there. Graham was on the paper. All credentialed people. It's published in peer-reviewed journal. Okay. So what happened is we can look at and we can make a chart. We can say, okay, let's count the. We had a computer had to write a program to count how many times the cow got shocked that day. How many transits did she get exposed to? And then we looked at how much milk she produced. And there's a 96.5% correlation between the dirty electricity on the wire, okay, the transients, and her daily milk production.
Mm-hmm.
And we didn't do it on one farm. We did it on like 5 farms in a row. And the day your milk production went up, so did mine. The day mine went down, so did yours.
Okay.
So the only 2 things that the people had in common was the weather and the electrical grid.
But that's dirty electricity affecting the cows. What
Yes.
about stray voltage? Do we have?
What happens is when we have dirty electricity, that's the problem. You get the dirty electricity, that high frequency transients that gets out to the transformer. And then it gets on the utility system. It's like sewage. Doesn't matter if it's just you and your wife or if you and your wife and kids and everybody else, right? When you flush the toilet, once it gets out to the main pipe, it's no longer your responsibility. You understand? So if you have good wiring in your home and everything, and once the electrons get back out and cross the transformer onto the primary circuit, the electric utilities, we're back on the grid now. They need to supply a wire big enough to take that current back to the substation. But they don't. They put it in the ground. What they did is went out in the street, instead of digging out and putting a big pipe in, they drilled a hole. So the dirty electricity is what caused that wire to become overloaded. If we went back to the loads of the 30s and 40s and 50s, we wouldn't have that ground current. It'd be very little.
So these 2 phenomena are linked.
One caused the other, yes.
Yeah.
So now, because we plugged that, even the good clean water from your, kitchen faucet, you go with a drink of water and even that's coming up. See, so now even the good clean 60 cycle, which there isn't anymore, but even the 60 cycle and stuff is getting out, spewing out all over the earth.
So we're overloading So with all these new devices, these various energy saving devices, and everybody's keen and understandably keen to save the planet and think they're doing a good thing, we're often 9 times out of 10, nearly always, we're creating a dirty electricity problem. And then certainly in North America, where we have this particular situation of the neutrals going back into the earth, we're also creating a stray voltage, or we're creating this AC current, which is in the earth. Which leads me to this question. I want to ask you about this phenomenon, which is called earthing. Okay, so earthing, going barefoot, and all different ways of connecting with this so-called beneficial energy of the earth, because the earth has, I'm sure you've observed this, it's got its natural DC electron supply flow in that charge voltage. So there is this natural DC voltage in the earth. So what's your view on that? Because obviously, there is a lot of there is certainly some science on this earth in question, and there are a number of people who are for it, and people that are certainly, there is anecdotal evidence that the earthing is beneficial. What is your take on this?
Okay, I have the measurements to prove it. Okay, the earthing thing originally started in Europe. Now, if you were Europe uses an open delta system. They do not use a grounded Y system. So the current that came out from the substation on a wire only has one way back on a wire. Okay, so the ground is at like zero potential, you could say. Okay, so now if you work on a computer all day, sit under fluorescent lighting, all these things, you will build up a charge in your body. There's actually an oscillation in your body. We can measure it. It's expensive meters, but we can measure it, okay? So if you lay on a conductive surface or stand on a conductive surface, you will discharge, okay? Now, whether it's connected to the earth or not doesn't make any difference. You can pay $150 and buy this earthing blanket or whatever they cost, and you can plug it in. In Europe, you're going to get some benefit because you're discharging. If you didn't plug it in North America, you would discharge. But you can also just stand on a piece of aluminum foil that you can go down to Walmart and buy for $20. You can buy probably a 10-year supply, and just stand on that. You'll do the same thing. Okay, you will discharge. But in North America, if you connect yourself to the ground, you need to take a voltmeter first and touch the one lead of the mat and the other to where you're going to connect that wire. And you will not connect yourself to that ground. Remember, in 1998, 70% of all the current that went out on the phase wires returned by the earth. And if you use the ground plug, the rounded plug on your outlet, that wire goes back to your service panel. From there, it's a direct connection right out to the primary neutral on the power line. So would you climb up the power line, connect the wire to the bottom wire, bring it down into your house, hook it to a blanket and conductive surface and lay on it? That's exactly what you're doing when you plug that wire in.
Yeah.
So in North America, no. Is it good to discharge? Yes. So if you bought the blanket, don't try it without plugging it in, and you'll feel a lot better.
Okay. So practical question. To deal with dirty electricity and to deal with stray voltage, can we, in the bedroom, for instance, flip and in the surrounding circuits, flip the breaker switch to eliminate this dirty electricity and stray voltage?
Okay. If you flip off the breaker switch, you're only killing one circuit. That's the hot wire. There's a neutral and there's a ground that's still there. So the dirty part is still going to be there, okay? And when we use the filter, we're taking it off the hot wire and we're putting it onto the neutral. But the problem with the neutral, or we're taking off neutral, put it on the hot, because we short it right across, okay? So the black wire, which is a hot, and a neutral are always 180 degrees out of phase with each other. So if you put something's plus 50 millivolts and you put it over to a negative signal, you get negative 50 millivolts. So if you got what's plus 15 minus 50? 0. Okay, so that's, you get better results with the filter. Okay, but if you feel more comfortable turning the breaker off, fine, but then it's a mess. You got to go down, turn it on, turn it off, but you still don't break the ground. You can't filter the ground.
So we still have this stray voltage through the ground. We've still got this electric field from this stray voltage. That's what you're saying.
From the earth, yes.
Yes. Okay, great. Okay, well, great information. Anything else that you would like to share with the viewers here?
Well, I think if you go to StetzerElectric.com, you'll find a lot of these papers, published peer-reviewed journals. If somebody has a question, they can call. I mean, I might not get right back to you right away, but I'm going to get back to you. There's nobody that I haven't returned the calls to. Yeah. And email, I always answer my emails. So, I mean, if you have any questions, you can call or find out. And, as long as it's about electricity. But these, and also these published peer-reviewed papers are, like I said, and the number on that GS meter means something. Like Millen did some research at a school, the Quintus School in California. And if that number is above 2,000, okay, and you work in that environment for 6 hours a day for 180 days a year, you've increased your chance of getting cancer by 25%. If the number is above 1,000, you've increased your chances of getting cancer by 15%. Okay, so the number means something. I mean, I didn't do the research, but they actually mean something. So you want to get those numbers down as best you can.
Yeah, which is important, and I'm glad you said that, because cancer, and that's an important subject, and it's a subject which it's an emotionally charged subject. So there is this link with cancer, with this phenomenon which we call dirty electricity. Dave, listen, thanks so much for being part of this House Summit. Sharing this amazing information, but also for all your contribution over the years, because you've been at this a long time. On your website it says since 1974. So it's very impressive, and the work you've done, in bringing this, sharing this to the wider population and helping people. And I'm sure you've helped so many people improve their lives. You really are truly a pioneer on this.
Yes. Well, thanks. I'm an electrical expert. I wish I was a marketer, and if I was, I would be. Everybody would know about it. But it's people like you that actually deserve the credit, because this is an engineering problem. I can come up with an engineering solution to an engineering problem, but I'm not neither Graham nor myself or marketers. And we have the best thing on the world. Now we have other people who are trying to make knockoffs of it, but they can't answer the question. They're still not doing it right. And I don't feel like subsidizing my competition, but because we invested so much in it. I mean, we made the trips to Russia and nobody paid us and things like that. So, but it is guys like you that are actually getting, so people hear your broadcast and then they try them and they get better.
Yeah.
So then they tell their cousins, uncles, brothers, or whatever. But it is guys like you that do this. And I do a lot of interviews, okay? And I have to say, there's Patrick Timponi out of Texas, and absolutely you guys you impressed me. You went to the top of the list.
Thank you.
You really did it. I'm not just saying it.
Thank you, sir. Okay. So, and also for everybody who's joined us today, thank you for being part of this movement. Stay tuned for our next session. Thank you. Bye-bye. Take care. Bye-bye.